Huawei CloudMatrix 384 versus NVIDIA NVL72. Who is the future of AI computing power? In June 2025, as the scale of AI models continues to expand, computing infrastructure has become the core battlefield for competition among major technology giants. Huawei's CloudMatrix 384 CM384 for short system is directly comparable to NVIDIA's flagship NVL72 architecture. Both are aimed at large model training, reasoning, and the construction of ultra-large-scale AI clusters. So, what does CM384 mean? Does it really have the strength to surpass NVL72? 1. System-level comparison. CM384 is big and strong. From the overall system specifications, CM384 integrates 384 NPU's Ascend 910C, which is much higher than NVL72's 72 NVIDIA B200 GPUs, according to the data. CM384's system-level AI performance BP16 flops reaches 300 petaflops, exceeding NVL72's 180 petaflops, and the performance is improved by about 1.7 times in terms of communication bandwidth. CM384 has a scale-up communication between nodes within the system bandwidth of 1075.2 TbS, which is almost twice that of NVL72, and a scale-out scalability between systems bandwidth of 153.6 TB per second, which is 5.3 times that of NVL72. This bandwidth advantage means that when training models with hundreds of billions or even trillions of parameters, CM384 can provide more efficient distributed communication capabilities, reduce synchronization delays, and improve overall training efficiency. However, all this is achieved at the cost of higher energy consumption. The system power consumption of CM384 is 599.8 to 1 kilowatts, which is 4.1 times that of NVL72, and the number of cabinets occupied has reached 16. NVL72 is 1, which places higher requirements on the deployment environment. 2. Single-chip comparison. B200 is still stronger than 910C, although the CM384 system performs strongly at the microarchitecture level. The performance of each Ascend 910C NPU is still significantly different from that of NVIDIA B200. In terms of single-chip AI performance, BP16 B200 is 2.5 pflops, while 910C is only 0.78 pflops, with a performance gap of up to 3.2 times in terms of scale-up bandwidth. B200 is 7.2 TbS, 910C is 2.8 TbS, with a gap of 2.57 times. Both have the same scale-out bandwidth, both at 0.4 TB per second. In terms of power consumption, 910C has a power of 1.56 kilowatts, slightly lower than B200's 2.01 kilowatts. In terms of AI performance to power ratio, PFLOPS kW, B200 reaches 1.24, much higher than 910C's 0.5, with a significant efficiency advantage. Therefore, although CM384 achieves a total advantage at the system level by stacking a large number of NPS, B200 is still ahead in terms of unit computing power and efficiency. 3. Technical and strategic significance. The launch of Huawei CloudMatrix 384 marks an important step for Chinese manufacturers in the field of AI infrastructure. It demonstrates Huawei's ability to build an AI cluster-level platform, especially in terms of communication, architecture, and large-scale system integration, which has achieved order-of-magnitude suppression over NVIDIA NVL72. However, it is worth noting that this advantage is based on quantity and system stacking, rather than a single-chip performance breakthrough. In terms of core indicators such as energy efficiency ratio and performance density of a single processor, NVIDIA still maintains a leading position, which has an important impact on model training, accuracy control, heat dissipation design, cost control, need for redundancy, etc. 4. Who is more advanced? From the perspective of system scale, CM384 is obviously larger, heavier, and stronger, suitable for deployment in extreme scenarios such as national data centers and ultra-large model training, while NVL72 is more compact and efficient, suitable for mainstream AI training scenarios. Especially in energy-sensitive enterprise environments, it has more practical value. In other words, CM384 is demonstrating its extreme capabilities, while NVL72 still holds the advantage of technical efficiency. Conclusion: CloudMatrix 384 is a powerful demonstration, marking Huawei's direct challenge to NVIDIA's technological hegemony in the AI infrastructure track. However, from the chip level, B200 is still the industry benchmark. The real competition is not only about who can build the largest system, but also about who can achieve the better balance point: high performance, low power consumption, and scalability. In today's increasingly computing-intensive AI technology, the duel between CM384 and NVL72 may just be the beginning.